Hello, hello. Today we are going to talk about special products. So some multiplying polynomials that follow patterns so that you can multiply them really quickly if you just memorize the pattern. And then we will also throw in a little unmultiplying with a greatest common factor, and we'll work on factoring. So let's start with a sum squared. Sum squared looks like this: a plus b, so that's the sum, and then squared means we're going to square it. Remember that when something is squared, that means you multiply by itself twice. So this is actually a plus b times a plus b. And remember, when you have a binomial, which is this thing, two terms, times another binomial, which is this thing, two terms, you FOIL them in order to multiply. So we multiply first items and we would get a squared. We multiply the outside items and we would get positive ab. Multiply the inside items, we get another positive ab. And multiply the last items and we get b squared. When we simplify this and combine like terms, we end up with a squared plus 2ab plus b squared. So the pattern here is that if I take this first term, and square it, I can take the last term and square it, and then this middle part is made up of the first term and the last term multiplied together, and then you double it. So for example, if I gave you this problem, x plus 3 squared, this x is like a, and the 3 is like b. So if I'm going to follow the pattern, a squared plus 2ab plus b squared, let me move this equal sign. The a squared, so if I square x, I get x squared. If I square b, I get 9. And if I multiply the x times the 3, I get 3x. That's the AB part. And then I double it, and multiply by 2, I get 6x. And that's it. I multiplied the whole thing out. If you forget that, you can FOIL it, but it's way easier if you know this pattern. Say, for example, I gave you 4x plus 7. This part is a, and this is b. So following our pattern, a squared would be 16x squared. B squared is 49. A times B is 28x. And then double that, and you get 54x. Plus signs in between everything, and that's it. So that's a sum squared. A very similar pattern is a difference squared. The only thing that's different here is that there is a subtraction sign in between the two values. So when I multiply them out, I would have a minus b times a minus b. When I FOIL them, I'm going to have a squared, but now I'm going to have a minus ab, another minus ab, and then plus b squared, because when I multiply a times negative b, I get negative ab. When I multiply negative b times a, I get negative ab. And when I multiply a negative b times a negative b, I get positive b squared. So this simplifies into a squared minus 2ab plus b squared. So the only thing that's different here from the sum squared pattern is this minus sign here. But we can use exactly the same steps. So say, for example, I asked you to multiply a minus, let's go with 8 squared. Using our pattern, the first term squared is a squared. The last term squared is 64. I multiply those two terms together, the -8 and the a, and I would get -8a. And then I double it, so I get -16a. Just double check your signs. This first one should be negative, the last one should be positive. So that's a difference squared. Same would be true if I have, like if I had two variables or more coefficients, like x minus 2y squared. Multiply the first term by itself is x squared. Multiply the last term by itself, it's 4y squared. Multiply x times -2y, and you would get -2xy. Double it would be -4xy, and that is the solution. Okay, a third special product is called a sum and a difference. Sum and difference. It's really a product of the sum and a difference, but basically this looks like this. A minus b, a plus b. And those can be switched, so it could be a plus b first and then a minus b. These are what are known as conjugates because the binomial, the parts, like the first and second part of the binomial, are exactly the same. It's just the sign in between that's different. So if I FOIL these out, I would have a times a, which is a squared, and a times b, which is positive ab. And then negative b times a is negative ab, and then negative b times b is negative b squared. So when I simplify all my like terms, what happens is these two middle terms cancel out, and I just get a squared minus b squared. So as long as these two binomials are conjugates, then my result is just going to be the a value squared minus the b value squared. So for example, if I have, let's go with n minus 7, n plus 7. The first value is n, so n squared. The second value is 7. So what's 7 squared? It's 49. So minus 49. That's it. I FOILed it. It's multiplied. These are actually some of my favorites because they're super easy. If I had something more complicated, like say I had 2x plus 3, 2x minus 3. These are conjugates because they're exactly the same thing with the signs that are different. So take the first term and square it, 4x squared. Take the last term and square it, and you get 9, and then it would be a negative sign in between them. Cool, so those are the special products. All right, lastly, let's switch gears for a moment and talk about a GCF. So GCF stands for Greatest Common Factor. And it's going to be the largest factor that divides evenly into every term in the polynomial, okay? Now, remember the factor could just be a number. It could be a number and a variable. It could just be a variable. So, for example, if we had like 3x cubed minus x, common to these two terms, what do they have in common? Well, they have an x in common. So the greatest common factor of this would be x. And if I asked you to factor it using the greatest common factor, that means you're going to take that x and you're going to unmultiply it from each of the terms. So we write the x on the outside, and then think for a moment, okay, if I take this 3x cubed, what I want to divide x out of it. So if I divide an x out of 3x cubed, what's left behind is a 3x squared. If I divide x out of x, what's left behind is 1. So I changed what was a subtraction expression into multiplication because I took an x out of this thing and wrote it as factors. That's why it's called factoring. Notice if I distribute the x, bloop, bloop, if I distribute it back in, I get 3x cubed minus x, which I have to, because factoring doesn't change the value of the expression. It just changes the way that it's written. Okay, so that's a GCF. We'll do more with those later. Thank you.